This week I'm going to be showing a lot of progress only because I finished. Now that I'm past chapter 7, I can show all the reading that I did for chapter 9 and 10. I finished chapter 10 today. So for problems, I have completed all of chapter 8 problems, which went by a lot faster than chapter 7. Of course, it's a much shorter chapter. And so tomorrow or next week I'll start on section 9.1 problems, convergence in R to the n. And chapter 8 was Euclidean spaces, so basic vector calculus. Or not so basic actually, because it's at a higher level. So yeah, norms, the 3 norms, Euclidean norm, L1 norm, subnorm, or infinite norm. Yeah, and then a little bit of matrix algebra, and I read an appendix, of course. The triangle inequality gets used a lot, of course. Then the Cauchy-Schwarz inequality, and then for the reading, yeah, all the way to the gates of the 2 gigantic chapters, 11 and 12. 11 differentiability in R to the n, 12 integration in R to the n. So altogether, these 2 chapters, when I finish them, which I suspect is going to take me probably 3 weeks each, maybe a little longer, I will be pretty far along, friends, pretty far along. So I will be up to here. I will be on page 448, and I think this book goes up to like 590. So this is going to be my major big thrust. Try to get 11 and 12 done. And yeah, today finished chapter 10, all about metric spaces. I did order a book by Halmas on metric spaces, measure theory, I should say, and I got completely lost. It's way above my level. So there you have it. I tried. But this is pretty cool stuff, of course. You know, you folks know that I love this stuff. And yeah, lots of fun reading. Then when it comes to my progress, I am reading up to, I finished chapter 10, so I'm really 5 weeks ahead of my planning, and I will continue to do that. I want to be always ahead. And so we are here, week of the 20th of March. Then for reading, this week I was able to read all of chapter 10. Of course, it's a small chapter. I can do that. I mean, I noted down section 7.4 was 12 pages. I think I spent a week on section 7.4. So just to give you an idea of how hard 5 and 7 were. 8, 9, and 10 have been a lot more readable. Of course, 9 and 10 are sort of copies of each other, if you will. Even in the book, as I mentioned in the last video, the author says do one or the other, but not both. But I did both. Then, of course, problems for chapter 8. 5, 5, 5, 3. Well, I think I may have tried problem 4 of 8.4. I don't remember right now. Actually, I could probably find out because I'm going to be looking at my notebook. Then, actually, yeah, I can do that right now. Let's see, did I do problem 8.4? No, I did not. So that's correct. So where I left off, I did some review of vector calculus. I even got me a copy of Marsden and Trumba vector calculus, and I think I need a good review. I should have done that, but I really want to finish Wade. And I know enough vector calculus to be dangerous from engineering, so that was okay. Solved some problems, got some help from the web on methods for at least one of them, and then figured out how to do the ones in the book in Wade. And so here they are. I can still do matrices. I did not have to look this up. I just did it. I was like, yeah, I know by 3 by 2, 2 by 3, 2 by 1, 3 by 1. I know what I need to get at the end. This one as well. Then getting into a little bit of topology, a few topology proofs, interior, boundary, closure. Very interesting how the book explains how you can get a partial covering, and sometimes you do not. So, yeah. But I need to get better. I screwed this up when I did it originally. Then I went and I plotted it in Desmos, and I'm like, oh, I got to be more careful. So I know it's a reading, it's a first round reading, but I still should be more careful. And then here we go with the gigantic reading. This is 3 weeks of reading, all of chapter 9 and 10. I think it's like 433 to 345. So 90 pages of reading over 3 weeks. So that's 30 pages a week. That's not bad for comprehension, not just like transcribing. So you got the norms. Separable sets. I looked it up and looked some things up in ChatGPT, but I'm getting more careful. Like, I'm not sure some of this is correct now that I've read chapter 10 and 9. Limits for R to the N sequences. Building up to the Heim-Borel theorem. With a Borel covering lemma, and then going into Heim-Borel, which says for a subset, E subset of R to the N, E is compact if and only if E is closed and bounded. And it's explored further in chapter 10. I tried to do as many drawings as I could of the text. These are not in the text. I'm not sure if they're correct, but I like to draw it out just because I'm a visual learner. I did look up examples of compact sets in ChatGPT. Then at some point, let me see where it is. Of course, the bow tie set. Just figuring out how coverings work. Oh yeah, at some point I found these great lectures from Staker. I think I'm going to try to find the link, put it in the description of this video, where he goes over the Cantor set. I've never heard of it before, so I learned that. Well, I think my son knew about it, which is crazy how young kids these days learn things so early. When I was his age, I wasn't learning nearly as much because I didn't have Google and I did not have YouTube. So yeah, I took notes from his videos to understand how coverings work, subcovers, finite subcovers. And then got back to my reading. Got back to my reading. Limits in 2 dimensions, limit proofs. Yeah, whether it has a limit, where it doesn't have a limit. I need to revisit all this, of course. That could be said about everything that I'm talking about here. Then, because chapter 9 goes back to the one-dimensional real space field in chapter 3, all the theorems, and then revisits some of them with their versions in R to the N, I wrote them all down and then marked for coverage which ones are done in R to the N. And then, of course, when I went through them, I also put down where they are in chapter 3. Continuity. Then using some topology, of course, the ball, compactness, connectedness. Yeah, E is open sets. The reverse image is open. All very interesting stuff. I draw this from a hammock. Hammock is where I learned how to draw these set diagrams. What a great book. Quoting back to the extreme value theorem. Lots of contradictions, so I noticed there was a theme here. in a lot of these proofs. Wade uses contradictions a lot in his proofs. Collections of subsets, collections of open intervals, an open covering. A compact set is always closed. A closed subset of a compact set is compact. Then, of course, in chapter 10, it's again revisited with using metrics, using a metric. Lindelof, which is revisited again. Yeah, and a most countable subset. Yeah. I gotta dig into what measure 0 is. Gotta dig into measure more. Points of discontinuity. Then the use of point oscillation and range oscillation. Also more to look into. It was dealt with very briefly, almost like as a finishing section. So I'll have to dig into that further. The closed graph theorem, I want to dig into it a little more as well at some other point. It's got a long proof. And it says I, a closed interval, a function of from I to R, real space, real field. Then F is continuous on I if and only if the graph of F is closed and connected in R2, two-dimensional real space. Metrics, using the triangle inequality for metrics in proofs, in definitions. So yeah, chapter 10 goes through a lot of chapter 9 and some earlier chapters and puts in a metric where you would normally have had a difference between functions. So f of x minus f of a absolute value less than epsilon becomes this tau function evaluated at f of x and f of a, which is really a measure. So a little bit of ChatGPT sneaked in. So there's a lot of x's in metric space. Yeah, discrete spaces, which the discrete space is a very interesting metric. Where is it? It's either 0 or 1. There it is. It's either 0 when x equals y or 1 when x does not equal y. So that's it's an example of a discrete metric. Yep. Of course, went back all the limit theorems, how they all went, and then of course there's limit theorems now using metric. Yep, cluster point. So some topological concepts. Interior, closure, and boundary, but now done with metrics in metric spaces. Boundaries. These deltas are the boundaries. Yeah. Lots of boundaries in this proof. I have a fly going around. Again, revisited these what was used for coverings or partial coverings, but now within the context of metric proofs. Yeah. Compact subsets, relatively open and relatively close sets. A little confusing, but then when I went through this example, I think it helped me understand it. Yeah, how you can take another set and say, yeah, E is relatively open in Y, or E is relatively closed in Z. So there goes chapter 10 reading, and that is 3 weeks of reading.